So 249A, that's what we're working on today. Or, sorry, 249B. A was yesterday. So if we had x squared plus 6x, oh, let's say, nice try, plus 8 equals 0. So one way to find the roots is to factor, or you could use a quadratic formula, or you could graph it, or you could complete the square. So completing the square is what we're going to practice today. We need to move that 8 to the other side. X squared plus 6x, leave a space, equals negative 8. And the basic idea of completing the square is you're going to turn the quadratic into a quadratic that has two identical roots. So if this piece of the quadratic has two identical roots, what would the roots be? Well, is there a number that factors into two identical numbers, and when you add those two numbers together, you get 6? It would be x plus 3 and x plus 3. And essentially, all I have to do is cut the 6 in half to get the 3. And then there are actually two versions of x plus 3, so you square this. Well, x plus 3 times x plus 3 is actually x squared plus 6x plus what? Plus 9. And if I randomly add 9 pounds to the left side of a balance, I also have to add 9 pounds to the other side. And now that equals 1. And then we would square root, and we get x plus 3 equals plus or minus 1, and subtract 3. Negative 3 plus 1 would be negative 2, and negative 3 minus 1 is negative 4. Okay, so that's a review of your sophomore year. We're going to do the same basic idea here, except we're not trying to find roots. We're trying to change how an equation looks. Quadratic equations can be written in two forms. The first is called standard form, and it's the one you're most used to. It's ax squared plus bx plus c equals 0, or equals y. And then there's another one called vertex form. And in vertex form, it's y equals a times x minus h squared plus k. Let me double check and make sure they're not going to do something really crazy on you. Okay, good. There is a slightly more complicated version of this, but luckily they were smart enough to ignore it. So, how do you convert from one to the other? Well, going from vertex form to standard form is really easy. If I had 4 times x minus 1 squared plus 3, how is this graph transformed from the original x squared? So we start on the inside first. Right 1, what does this do? 4 times as tall, and what does that do? Up 3. How would I turn this equation into one that looked more like that? Well, you would do x minus 1 times x minus 1, which is x squared minus 2x plus 1, and then you times that by 4, and once you brought the 4 in, then you would add 3. So going from vertex form to standard form is really easy. Going from standard form to vertex form is a little bit more difficult. So that's what we're going to do today. And essentially, you're going to complete the square with just a few minor changes. So let's say I had x squared plus 8x minus 5. Okay, and this is y equals. The difference here between finding the roots, I don't move that negative 5 to the other side. Because in the end, I want an equation that says y equals. So I'm not going to put anything on the side that y is on, because if I do, I'm going to have to bring it back in the end. So instead, all I'm going to do is slide this out of the way. So I get x squared plus 8x. I'm going to leave a space. And if I just kind of move it over, does it turn into positive 5? No. If you move it to the other side of the equation, it becomes positive 5. So it's just negative 5 out to the side. Okay? And then if I create a perfect square of that quadratic, what is the factor? X plus 4 and x plus 4. So x plus 4 to the second. Well, what number would go in this place? 16. But can I just randomly add 16 to one side of the equation? No. What do I need to do? Add it to the other side, but I don't want to put anything on the other side. So is there a way that I can add 16 here and still keep the equation balanced? Subtract that 16 later on. So we're going to add 16 here, and I'm going to subtract 16 there for a total change of 0. Does that make sense? So you could add the 16 over to this side, but then you're going to need to subtract it anyway. So whatever you add, you have to subtract it off to make it work. So we have x plus 4 squared, and then minus 5 minus 16 is minus 21. And that is now in vertex form. So that graph would be left 4 and down 21. Does that make sense? Well, it does. So this 16 is necessary to create the x plus 4. So that negative 16 combines with the negative 5 to make negative 21. So we need that number in order to create this. But by creating that, I added weight that shouldn't be there, so I subtracted that weight off. So overall, I didn't make any changes, but I just put it in two different places to accomplish what I needed to do. So let's try another one. So x minus 12, x squared minus 12x plus 3. So y equals. So that would be y equals x squared minus 12x. I'm going to leave a space, plus 3. Well, can this quadratic be factored into two into two of the same factor? What would the factor be if the middle number is negative 12? X minus 6 and x minus 6. Well, if this is x minus 6 squared, what number goes there? Positive 36. But if I add 36 to one side of the equation, I have to subtract it off on that same side of the equation in order for it to remain balanced. Do you get that, Aubrey? So I'm going to put minus 36 out here. Now, this factors into x minus 6 squared, and over here I have minus 33. So this original quadratic, written in vertex form, is right 6, down 33. Okay? It's a little bit more complicated if the middle number is odd. For instance, x squared minus 9x, let's say minus 12. So y equals x squared minus 9x, leave a space, minus 12. What number goes in here? And you can use 4.5, but it's usually easier to use the fraction. So x minus 9 over 2. And it's easier because fractions are much easier to square than decimals. I don't know what 4.5 squared is, but I know what 9 over 2 squared is. 9 squared would be 81. So I'm going to add 81. And 2 squared would be 4. 81 over 4. So over here, I need to subtract 81 over 4. Or add. No, subtract. That's right. So negative 12 plus 81 over 4, math fraction, plus 33 over 4. No, I did that wrong, didn't I? I need to subtract. That number seemed a little small. So negative 129 over 4. Do you guys get the hang of that? Okay, now let's do... We'll get to that. All right. Now, the more difficult problems are the ones where there's a number in front, where there's a vertical stretch, where you're pulling it vertically or you're smashing it vertically. For instance, 2x squared plus 10x plus 5. Okay. Can I divide this by 2? No. But I kind of need to. So I'm going to set it up like I did before. 2x squared plus 10x, leave a space, plus 5. But completing the square only works if the number in front of the x squared is 1. So I need to pull a 2 out. 2 times x squared plus, let's make this easier on us. Change that to, well, you're probably not writing this down, but I'm going to change it to a 12. Plus 12, nope. Plus 6x, leave a space, plus 5. Notice, pulling a 2 out did not affect the 5. Yes. Just regular paper will work. Okay, so this is going to be x plus 3 squared. So what do I put there? This is plus 9. So what do I put here? Not 9. Not negative 9. It's right. It's not really a 9. It's a 9 that's hiding underneath a 2. So everything in here is actually twice as big as it appears. So when that 9 comes out, it has to hit the 2. So I'm going to subtract 18. And there's a 2 out here, and that would be negative 13. So for this one, right 3, or left 3, twice as tall, and down 13. Now, if this number is negative, you need to pull the negative out when you pull out the 3. If it's negative 1, x squared, you need to pull out negative 1. So if I had y equals negative 5x squared plus 30x minus, I don't know, 12. I'm going to set this up as y equals negative 5 x squared minus 6x, leave a space, minus 12. Does everybody understand that? Okay. Oh, this is the same, whatever. X minus 3 squared. So this is a plus 9, but I didn't really add 9. What did I add? Negative 45. Because that 9 is hiding underneath the negative 5. So we actually subtracted 45. So I need to add that back on over here. Oh, yeah. 45. So this would be plus 33. Well, so this 9 is actually negative 5 times 9, which is negative 45. So I really subtracted 45, so I need to add it back on over there. Okay? What's that? Well, I don't understand. What do you mean? Well, that's what it means. Yeah. So the instructions say, so you're looking at 23 to 34. Rewrite the quadratic in standard form by completing the square. So yeah, they've got standard form backwards. They've got their forms mixed up. I guess technically. Yeah. Um, so yeah, what they mean is rewrite the quadratic formula in vertex form by completing the square. And then on 35 to 44, you're going to convert it into vertex form so you can graph it without a calculator. So for this one, all you need to do to graph it is it's going to be right 3, up 30, and then reflected and made 5 times thinner and up 33. So it would look like this. And that's a good enough graph for me. If you state where the vertex is, and then you get the direction right, and you basically get the thinness right, that's as much as I want to see. Okay? All right. Did you want to see one with fractions? Were there fraction ones? Uh, okay, let's do 33, because those are a little bit harder. All right, 33. So y equals, I'm going to pull out 1/2. How do you take a 1/2 out of negative 4? Well, what times 1/2 is negative 4? Negative 8. So it's actually x squared minus 8x, leave a space, plus 3. Okay? So y equals 1/2 times, what is the factor? X minus 4 squared. And 4 times 4 would be plus 16, but it's not really a 16. It's half of 16, which is 8. So if I add 8 on the inside, I subtract 8 over here, and minus 5. That one was actually really easy. So that graph would be right 4, half as tall, and down 5. Let me double check. So you don't need to do 34. Take a look at 43. How are you going to do 43? So what is the middle term in this case? 0. Half of 0 is 0, and 0 squared is 0, and then you'd subtract 0. So that is in vertex form, right? In that case, if you're missing the x, vertex form and standard form are the exact same. Essentially, it's saying 1/2 times x minus 0 squared minus 1/2. So you go right nothing, half as tall, and down 1/2. So if you're missing the x term, vertex and standard form are the same equation. All right, get to work. 240, we're on 249B.